to a 4. Because it shows me you understand it, not that you can just sit there and plug in numbers and memorize a process. It shows me you understand it. All right, we are recording. All right, so we did that when we did partitioning. We're going to review that partitioning at the end of class. Right now, let's go into the midpoint lesson, which is actually a pretty fast lesson. So look at the first example, which is page 33, I believe. I don't know if these pages match up. Yeah, they do match up. Good. Even better. Oh, no, that's not. Was page 3 your first, 33 your first? Is that the first page of this lesson? It should say midpoints and bisectors at the top. It's 31. Okay, so these pages do match up. Good. That makes it easier to find. All right, so what is a midpoint we said? Crickets. It is the middle, the midpoint is the middle of it, but how do we know mathematically? How do you prove it's the midpoint? What would you have to be able to do to prove it's a midpoint? We don't do that. So let's talk about that. If I took the endpoint, so let's say we say the left endpoint is the starting endpoint, and then the right endpoint is the ending endpoint. If I take the right endpoint and I subtract the left endpoint, what does that do? Because kids do get confused about these two things. What does that do? Taking the right and subtracting the left. I can't find, oh, what does that do? Rickets. So there, I take that right 18, I subtract 3. What's that give me? What is that? 15. What does that mean? That's the length of the whole line. So you need to understand, because some formulas you will have on the EOC, some you, or on the district, some you won't. So you need to have an understanding. You're never going to memorize everything you need to know for these tests.
For the finding the midpoint, add the 2 endpoints together and then divide it by 2.
So we said the midpoint formula is pretty simple. I take the two numbers, add them together, and they give you this weird formula, sort of weird stuff. You take the two numbers, add them together, the two endpoints. You divide by 2. I get 21 divided by 2. That's my midpoint. And what's that? I say this lesson's not super, super tough, in my opinion. It will definitely be the easiest stuff on your quiz next week. The first thing we do will be the very, very easiest. The second thing we do, which is still midpoints, will be the second easiest. And then the partitioning will by far be the most difficult. So let's look at the example. Now, here's one more thing you can do. Let's do it this way. So you go into the bottom of the, oh, so there's the formula. They do the x1 thing plus x2 divided by 2. X1 and x2 are just they're the endpoints. That's all x1 and x2 are. The 1 and the 2 are not math operations. It's not like when you have x raised to a second power, so you have that little 2. That's a math operation. This is not, this 1 and this little 2 are not math operations. They're just telling you this is referring to the first endpoint. This is referring to the second endpoint. Otherwise, you wouldn't know which x I was talking about. If I just said, what's the value of x? You'd be like, well, which x? Are you talking about the A or the B? So x1 just means the first endpoint. X2 means the second endpoint. That's all that means. No, not a math operation. Let me get rid of all that junk. What? And I just said this, so hopefully somebody can repeat it. Words. What did I say? How do you prove a midpoint is truly the midpoint? Like I can take a look at it and say, well, I think that's the middle. But how do you prove it? What would you do? Well, what do you mean both of the sides have to add?
like split.
So half is absolutely true. So what does that mean is true about those two segments?
They might.
Add up together. Let's correct that because I think, so again, this is when we get confused when lessons are similar. We said that if I have a point between those two, well, here, we'll do it up here. If I have a point between those 2 points, so I have an M, that's, in this case, it is the midpoint, but any point between 2 points means the first segment plus the second segment will equal the long segment. That's for any point in between, doesn't have to be in the middle. So that's kind of what you're saying, even though I think you know what a midpoint is, I believe. But let's make sure we get it correct, what you would say. That's what I want you to say. That a midpoint means, and they will still add up to be the whole length. That is still true. But to know that it's the midpoint, we have to say the left length is equal to the right length. So in this case, we'd say AM equals MB. And again, that means the length of AM is the same or equals the length of MB. This is only true for a midpoint. This is not true for any point in between. This, what we just said a second ago, and I'll write it on the formula, AM plus MB. So again, that's the length of A to M plus the length of M to B will always equal the whole length. That's always true. Doesn't matter where the point is. It could be way over here. It could be way over here, but this bottom thing will always be true if it's between the other 2 points. This is only true if it's the midpoint. So don't get those two confused. Kids do get them confused. Yeah. All right. So I'll, when I scroll up, that's gonna stay there. So I'll leave that there. So now let's talk about the midpoint and how to figure it out. We said there's a formula, but I'm going to tell you there's another pretty fast way to do it based on what we just said. If I know that the left segment has to be the same length as the right segment, really all I need is I need a point that makes 2 segments that are the same length. That's all I really need. So if I can eyeball it really quickly, and eyeball it just means look at it and tell where the point would go to make the 2 sides equal. I'm going to look at this. Clearly, it can't be way over here. It can't be way over here. I'm going to say, I think maybe that's the middle. Raise your hand if you think that's the middle. Raise your hand. Say, Mr. Gill's super smart. He's right. Or maybe Mr. Gill. I'm really smart. Think it's middle? Trust me? Yeah, you trust me? Sometimes I do stuff wrong on purpose. Go in some. Allie's not here now, but ooh, yeah. Oh, see, Emery's had me before. He trusts me. He got, oh, Mr. Gill's all. Let's see. What would be true if that's the midpoint? Now I'm really messing up. So if that is the midpoint, so I'm going to put it back where I had it. Now that I've zoomed in. If that is the midpoint, this line segment, so from this endpoint to that point, should be the same length as from this point to that endpoint. Is it? I'll visually show you it's not. I could just subtract and say 2 subtract -3, and I would have gotten 5. I could just say 8 subtract 2, but instead I'm going to actually count them out. Well, you know what? It's true. 1's 5, 1 is 6. So that is not the midpoint. What do I need to do with that midpoint? I need to adjust it. Which way do I need to go?
Right.
So what if I moved it to 3? What's going to happen? Then I would just have 6 on the left and 5 on the right. So eyeballing this isn't as easy as it can be in some problems. Anybody have any idea what I could do? I could split the difference. If moving it a full unit doesn't work, so if I move it to 3, now I'm just going to have 5 on the right and 6 on the left instead of the way I have it here, 5 on the left, 6 on the right. If that's the case, I'm just going to erase everything. that means I have to kind of split the difference and do it right in between those two. Now I would have, if I counted 5.5 and 5.5 on both sides, now that's the midpoint. But here's the thing. If that's all you do on a quiz, that is wrong. Because I don't know where you're putting that. You might be putting that at 2.4 or 2.3 or 2.6. So I don't know for sure yet you understand what the midpoint is. So you need to do one more piece if you're going to try to do it this way. You need to either tell me that number is 2.5 and just kind of write 2.5 up above it. Or you could say this, kind of like they do in some of the problems. They say from here to here is 5.5. And from there to there is also 5.5. And now you have shown me, I know that's the midpoint because I know that is equal to that. So if you're going to just put a dot on the line somewhere, you need to do that step. Because a lot of kids will just guess and put a line somewhere close to where the middle is. And they might be right, but I need to know that they understand why it feels this. So, and I'm fine with that. You didn't do any math. You just kind of figured out where the midpoint is. That's the midpoint. Again, the good thing about the new standards, you can pick the way you do it. You just have to show me that you understand the concept. What's the other thing we could do then? And this way is actually easier, I think. What's the other way? What's the formula? Just said what formula. What's formula for midpoint? So that's the like mathy version. But what are we just doing? Yeah. So what Tyson said is true. We're taking that door, or were you knocking on the table? Sometimes kids knock on the table and I think it's a door. Teacher. Yeah, nothing. This would be so easy up on games. What is that?
It's glitter.
I'm sorry, it's like just like hair massage, strengthen your forearm. I used to do that. Then I realized, wait, my forearms really aren't that. They're never going to get that big. So the formula is really just, I mean, they've got this whole x1 plus x2 thing, but remember, those are just the endpoints. So don't get hung up on the x1, x2. There is a formula where you do really need to understand what that means, but this one is just add the two endpoints. So in this case, my two endpoints are -3 plus 8. I divide by 2. What's -3 plus 8? Divided by 2 is what? Yeah, same thing we just came up with a minute. So either way works. I don't care which way you do it. You need to, if you're just going to say, I think the point goes there without doing all the math, you do need to show me somehow why you know that's the midpoint. But I'm fine with that if you show your logic behind it or your reasoning behind it. Why do you think we use the x's in the formula? Why do we choose the variable x? What do you think? Exactly right. So when we deal with points and line segments, a lot of the time we're going to be dealing also with graphing, which that's the second part of this lesson that we're about to do in a minute. The x-axis is a horizontal axis, right? It's just a number line. It's really all it is. So this right here is just a number line. It happens to be the x-axis, what we call it, but really it's just a horizontal number line. So whenever we have a horizontal number line, a lot of times they're going to use the variable x to represent kind of the x-axis, even though we don't have a vertical axis also. The next part of this lesson, though, we'll be dealing with a line on a graph on a coordinate plane, and then we'll have to use the x and the y values. So it's kind of a good idea to get used to it being x's and y's. Here's what I want you to do now. That was example 1. You need to now do, oh, wrong direction, I believe. Or maybe not, maybe it was right direction. Yeah, so we did example 1, page 31. You need to do the practice problems. So the page 37 says practice up top. 1 through 16 are all the same. I don't know why they gave you so many problems on this, because it's the same thing over and over and over again. Not that difficult, in my opinion. But start doing those 1 through 16. I'm going to cut you off in a little while, so you won't finish all of them. If though you are not, I'll give a couple answers out so you can check your answers. If you are not getting the correct answers when I give them out, you need to figure out why you're not getting them, either on your own or you need to come up to me. I'm only going to give you 5 minutes. So if you want to try to do it by eyeballing and looking at it, maybe on a couple of them, that's not a bad idea. If you want to then try to do the formula on some other ones also, that way you kind of have 2 methods you can use. The page is 37. Oh yeah, I'm sorry. Yeah, you will need calculators today. So if you want to, some of you already have some, not your phones. And don't be on your phones today, because I'm already mad at students and classes for being on phones. One class is already on the bad phone list, and they don't get to touch their phones at all. Like, no matter how much free time or independent time I'm giving, they don't touch their phones. They sit there and they twiddle their thumb. Well, what do we do for the incomes? I mean, what do we do for the midpoint? Wow. What are you trying to do? You can just look at it visually and make sure that 2 links are the same segment, the same length. Or you can do what? What do we say you can do? Write that down, page 37, 1 through 16, because I'm about to leave it. Page 37, 1 through 16 is what you're doing. Write it down now, because I'm about to leave it. Page 37, 1 through 16. Oh, actually, I guess I can do this for a second. Because I'm going to put the practice problems you're working on up on the board real quick. In a second, we'll do the first one together, and then I'll let you keep working for a minute. So Sergey, keep trying to figure it out, and I'm going to do that one in a second. And then after that, you should be good to go. Let's shrink that down. Yeah, and you guys can work together. I would encourage you to work together. Oh shoot, I forgot to do something. I had to pick them. Yeah, compare your answers especially. Is that a question? You had this shit? Sorry. Interesting. Yeah, you really don't need the, like, there's not a whole lot of copying down, so I'll just give you a copy you can work with. I had here. I had one out just for that purpose. I knew somebody was not gonna have it. I mean, that they were gonna know where they were, they just weren't gonna have them today. Here, let me make sure this is in order, and I'm gonna staple it. This is missing, I think, I hope it's not missing the problem page. Yeah, okay, it's got the problem page. So yeah, I'll give this to you. So yeah, just for today, just copy the problem. I mean, again, once you get this down, I think it might just be the third person. So you want page 37, 1 through 64. That's the answer. That's what you do is say negative. You don't have to draw anything out. Like, I just literally need what number is going to be the midpoint. -2 and the answer. Yeah, oh, absolutely. Yeah, your notes are for you. If you don't wanna work on these book pages and you wanna put it in your notebook, absolutely, wherever you want it. Your notes are for you. Or did it get on the wrong? Well, that just means that you had an answer up there and you had to subtract, so it's gonna use the answer and then subtract from that. Well, you did apparently. So you must, yeah, just clear it.
What?
It's world type in. What do you want to do? I don't know what it was doing before, maybe, but yeah, I think that's just in case you ever want to go back and use the answer you had. You hit a math operation button that recalls the answer that was. But if you put a number in, it should, it's not looking up six.
-2.
Or. Yeah, yeah, because if I say negative zero. Well, yeah, you're not always gonna get a decimal. I mean, a lot of times you'll get a nice round integer, sometimes you'll get a decimal. Well, whatever answer you get, that's the answer. And you know that because if I put a point on -2, I have 2 segments on the left, 2 segments on the right. But it's 30.
Wait, so number 2?
I'll give you another couple minutes and then we'll kind of compare answers. And then we'll move on. The first answer, just to kind of give you something that you can check, is -2. So number 1, you should have gotten -2. We're going from K to M, so that's the line segment we're looking at. The 2 endpoints for K and M are -4 and 0. So if I add -4 and 0, I get -4. I divide that by 2, I get -2. That's the midpoint. And I'm going to show you visually how that also can be done. And I'll do that in a couple minutes. I talked about the PBIS cards in here already.
Oh, yeah.
The lunch thing, I did that in here already. My classes all run together sometimes. I'll remember if I've said it. Give you another minute now, and then we'll go over some answers together, and then we'll move into the slightly more difficult next. I don't care if, like, when I'm doing this independent stuff, I don't care if you move around to work with somebody either. So there's something you know each other. Around, that's fine. As long as you're working, if I see you moving around, just sitting there and just chatting, and you never have anything done, that. You done with all of them? Did I give you one of those? And you want to know? You're done with all of that already.
That's unseated.
So if they're doing it tomorrow, you don't have to get the pizza or whatever they have tomorrow, but you can always save it for another Friday. All right, so let's go over some answers. Number one, we said was -2. What'd you get for number two? Oh, if you have a wrong answer, an incorrect answer, I'm not going to go over how to do these as a group because we got more difficult stuff we need to cover. You can come up to me or just try to figure it out on your own is the best way. And then if you can't figure it out, then you can get with me. You have to come by like later, like after class or tomorrow at lunch or something. We have a quiz on Monday. What's the answer to number two? -1, is that what I'm hearing?
Yep.
All right, -1. That sound good? What's the answer to number three?
0.5.
0.5. Everybody good with that? 1/2, 0.5. Answer number four. 2.5. We good with that? I remember that one from earlier. I don't know what number are we on? What's 5? 1. I do remember that one too. 1.5. What's 6 then? And that's all we're gonna. -2. We good with that? All right. So if you're not getting those answers, try to figure it out on your own because you learn more now that you know what the answer should be. We're going to go on though to the next thing, which is a little more difficult. I don't think it's horrible, but it's definitely a little more difficult. So we just did on a number line. So when we had an endpoint on the number line, we figured out the midpoint. Not too difficult. You can even do it visually, or you can use add the two inputs. It's a little trickier though if I give you this. I'll get that. Whoop. Whoop. If I give you a graph and I put a diagonal line on there, you can't just use, you can't just use like a number really and say, oh, well, that's just this plus this divided by that. Because it's diagonal. It's not on the number line. Like, I don't know. What do I do? Right? Or can we? How would I figure what's the definition of midpoint? It's still the middle. The definition doesn't change. It is still the middle of the line. But how do we prove it's the middle? What makes it the middle? How do we know for sure it's the middle? Good answer.
The point is each side should be equal.
Yeah, if we split that line into two equal segments, meaning the length is the same. That's how we know it's the midpoint. The problem is I can't really measure the length of that line going diagonally. Going left and right, I can just count. I can just say 1, 2, 3, 4, 5, whatever. I can't count diagonally and say that's the length of it going diagonal. It's got to be one more step we added, which isn't really even that bad a step. I don't know why my line and my letters are off, so let me fix that real quick. So we'll say this endpoint is B. Let's just move the A first. Oh, that was loud. So now that we have our endpoint, if there were a way for me to say, hey, I think that's the middle, and if I could somehow count and prove that both sides are the same, I'd be done. I wouldn't even have to do any math. Let me ask you this. Does anybody have a guess at where they think the middle could be on? Because there's a point I look at that I'm like, man, that's like the middle to me. Oh boy, someone can. I'm gonna go with Hannah. Take a guess. What do you think the midpoint is? Like just visually. That spot where I'm going through one, and you're talking about this one like on the y-axis, right? That kind of looks like the middle to me. And you know what is a good hint sometimes? If it's going right through like the corners of squares, like see how this, I don't remember if I zoomed all the way in or not. I did, shoot. Okay, so that's as zoomed in as we can get. If I'm going right through the corners of, like you see how here, I'm not going through the corners of squares here. I'm not going through I'm close to a corner, but I'm not going through a corner there. I'm not going through a corner there. If that's the spot you're looking at, that's probably a bad spot. It's just hard to tell what that number is. Like, I don't know what number that is on the y-axis. Like, I can't really tell, which means it's hard to make that a midpoint by visually looking at it. If that is the midpoint, we'll still be able to figure it out using our math formula. But if I'm trying to visualize it, probably not going to be able to visualize it if I'm coming up with a point that's not right on the corners, like that's right on the corner of all these squares. It goes right through the corner of all 4 of those. So now we got to figure out what, if that's the midpoint again, what would be true? What do we have to prove to show it's the midpoint, Emery? So it forms, what's true about the 2 segments that it'll form? They have to be what? If it's a midpoint, the 2 segments we're gonna, so let me just show you visually. So it's more, I know sometimes the words make it more confusing. If that is the midpoint, and I put a midpoint there, what's gonna be true about those 2 segments? They're gonna be equal. They have to be the same length, right? But I can't prove that they're the same length because I can't just, well, shouldn't say I can't. How can I prove it if I can't just count that way? Anybody have any idea? I don't really expect you to know this. I thought we're the first day, but anybody have an idea? If you get this, then you're in good shape. What about the coordinates? So I got an endpoint, so let me write this. So the first thing almost I would always do in these, by the way, if you're given points on, and this is any lesson, I don't care if it's about triangles, parallel or parallelograms, any kind of weird quadrilateral, any shape, label the coordinates. So that A is a -5, comma, -2. What is Stefan? What is the B? So I use the X value first, which was -5. I use the Y value first, which is -2. What's my B then? Yeah, I like him. I like him. Didn't even hesitate. He got up to look at it.
5, 4.
Perfect. So it's always X first. This is a quick reminder. X first, Y second. X and Y. So those are my 2 numbers for endpoints. Now, again, we have 2 numbers, so it's not like when we just had the one on the x-axis and we just added whatever we just did in all the different problems. Now, if I can somehow say that length is the same as that length, which Sade was talking about how we might be able to do it, how would you do it then using the coordinates? What were you thinking? Thought process.
This one back. So the X plus X1 plus. Like the top.
And what would we need? Are we done? Like we just add them together? What would we need to do after that? So you're using the formula. And that's what we're going to ultimately do. So if that just meant, I don't know if you looked at it and saw the formula or if that just makes sense to you, you're good. So you don't need to worry about what I'm about to do visually. You get that piece of it. I'm doing this right now for people that maybe are better at the visual and not the memorization, although I think they get this actually on geometry, this formula. Midpoint, I believe they do. I think I just printed it off today and I think it was on there. But still, let's say you get confused with, oh, what's this X1, Y1, X2? What is all that stuff going on? Let's still talk about the visual. If I can prove that length is equal to that length, I've found the midpoint. I don't need to do all that math. Here's how you prove it. I can't count this way, right? But do you remember how we did slope? What did we do with slope? Like how do you, back in the day in 8th grade, 9th, 7th grade, whatever, what did we do for slope? 9th grade. What were the 2 words? Slope was made up of what? I know, we're reviewing olds. Whoa, somebody's smiling. Who am I going to call on out of the 2 chatty guys? I'm going to call them both of them. You guys figure it out. What were the 2 things that made up slope? Lexla and Brandy. I'll go. I knew one. Super smart. Together they know. Did you know that together they know every? I can't do that. You both. It's a joke. I'll tell you a joke. Maybe. My buddy used to use it. He had a twin brother. I'm gonna tell you now. We're getting off camera. My buddy had a twin brother. They were never together. Like literally, I never saw it. So if we were out, he would say, "Yeah, between me and my brother, you may not even get this joke, right?" He said, "Between me and my twin brother, we know everything." There's nothing we don't know. So of course, like, what a lie. There's no way you know everything. So he'd be like, yeah, I give it to you. Like, ask me any question. So we'd ask him a really hard question. Thinking, oh yeah, my brother knows it. And his brother was never good. That was the joke. I thought it was funny. I'm sure you probably don't get it. So if I want to prove that those two line segments are the same length, I can count. I just don't count. So rise over run was the answer, by the way. I don't count diagonally. I count left and right and up and down. I count. So I'm trying to get to that point right there. I count 1, 2, 3, 4, 5. So I'm going to draw a little triangle in. So that length is 5. I then count up. That length is 3. That tells me kind of how big that triangle is. It really sort of tells me how long that is, even though I don't have a specific number for it. You did a long time ago, you did a squared plus b squared equals c squared. I was finding out the length of a side of a right triangle. So if I know 2 of the sides, that's really all I need to know to understand that if I can draw a triangle on those 2 points, and if I can get the same numbers, a 5 and a 3, that means that would have to be the same as that. So now I'm just going to count 1, 2, 3, 4. Well, 1, 2, 3, 4, 5. So far, so good. 1, 2, 3. I got the same numbers. The bottom side is 5. The right side is 3 for both of them. That proves right there that is the same length as that. If you don't get that, don't use it. If you get that, then that, if you can repeat what I just did on a figure, that's the midpoint. Let me do the other piece real quick, and then when I turn it over to practice return. So here's the and I hate, again, memorization versions, but this is kind of the formula part. Again, I don't mind this one as much because I think you do actually get the formula on your like EOC sheet.
So
Well, we're not subtracting. I'm about to do the other one you can do. Exactly. That's what we're about to do right now. This is the way that Sade was saying to do it. Again, I don't mind this way. I just like to show both ways, and you can pick whichever one you want. Like I said, with the whole new standard stuff, I don't have to force you to know both ways. You get to pick the way you want. So if I go from here to here, so now I'm going to draw one big triangle in instead of 2 little ones and trying to make sure that 2 little ones are equal. I'm going to draw one big one in. Now I have a segment that is a left and right segment on the bottom, right? The bottom side of that triangle is now just left and right. The right side of that segment is now up and down. Move that out of the way a little bit. So I have a segment that now is going up and down. It's still a line segment, it's just vertical. I can figure out the length of those 2. I could count, but what's the other way to figure out length if you have any number line, like left or right, up or down, doesn't matter. How do you figure out length, you said? Timothy?
subtraction.
Yeah, we take in this case, it's got to be the right endpoint, subtract the left endpoint. So we would do 9, subtract, and in this case, the endpoint is a -5. So what's 9 subtract -5? You'll have calculators, so I'm not super worried about math. Not 4. Nah, because if we subtract a negative, and if you go old school, that was your keep change flip way back in the day. So that number I got was 14. What did we do in the midpoint formula though? Because we're basically just finding the midpoint of this line. So we add them together, but then we do what? Sade, what did you say we had to do? After we add the 2 endpoints, we then divide by 2. So I divide that by 2. So that gives me a 7. That 7 is going to be my X value. So M is just, that's going to be the name of the point when I put it on the line. So there, that's my X value because I use the X values from the blue line. I use the X values, so that's why that's the X value. I now just do the same exact thing and I say, well, what are my 2 endpoint values for that line segment, the vertical? John, what? Oh, did you move to work with somebody back there? What's the, what are the endpoints for the vertical line segment? Can you see it? Can't see it, then I need you to back up here for this question. I'm just looking for the vertical number, so the number on that, basically. I'll give you a hint. I don't care if you help them if you can. So 4 is one of them. So 4 is the endpoint there. What's the other one? -2. So I'm just taking the endpoint values of these, which is based on the y-axis. Don't think you can use this as your endpoint. This and this go to the horizontal line. This and this, the 4 and the -2, go to the vertical line. All right, so if you're visually looking at it, don't think your endpoints are both 9 for that. You got to have 2 different endpoints if you have a line segment. There. So now I can go ahead and do that same formula using the 4 and the -2. 4 plus -2 divided by 2 gives me +2 divided by +2. So I'm going to shorten the math up and just put the answer. That means that is my y coordinate. Now here's the really good thing about it, doing it this way. I will know for pretty much for sure if I did that right, because if I go to put this on the graph, again, that's my x, that's my y. If I go to put that on the graph, it better fall right on that blue line, because it's supposed to be the midpoint of that line, right? How can the midpoint of the line not be on the line? So you kind of have a built-in check for it. So I'm going to go ahead. I'm going to say, all right, well, 7, 1. So I am not even close, right? I'm not anywhere near the blue line, right? So what did I do wrong? I know what I did wrong. What did I do wrong? And I didn't do this on purpose. This was my mistake. I made a mistake you guys make all the time. What did I do wrong? Nobody caught my mistake and were scared to say it because they were like, oh, he must have done something. Did something wrong. I did it right on the y, so this one's right. The y value is correct. What did I do wrong in that one down there? See if you can fix Mr. Gill's mistake. What's the formula for midpoint? What do we do with the endpoints? What did I do? I subtracted them, didn't I? It's a no. I figured out the length of that line and then divided by 2. I don't want to subtract them. I want to add them. So if I add them, somebody said 4 earlier. I don't know if that's because they got the math wrong or if because they actually were getting the right answer. Yeah, did you add them together? Yeah. So I did the wrong thing. That should have been 9 plus -5. And again, that's why there's a good thing. There's a check built into it. And I knew I wasn't on the blue line. So like I said, if you fall on the blue line, there's a pretty good chance you're correct. So that should have been a 2. Now, if I come over, I'm still wrong. That's not going to be the middle. 2 and 1. Add them together. 2 divided by 2, so that's 1. 5, 4 is that point. -5 and -2 is that point. Oh, I know what I did wrong. I think I'm blind. That's what I did wrong. What's the endpoint for the x endpoint for that point? 5. I wrote 9. I thought it was a 9. I just looked at the number and I thought I was going through the side of it. It's 5. I just can't see. That's the problem. So yeah, see, never ever think Mr. Gill is right. You never know when you just can't see or when he's going to make a mistake. So that's actually 0. So now I think we're finally correct. Well, no, because the 1 is correct. The y was correct. I was able to see that correctly and I did the math correctly on that. So now if I go to 0, 1, which is, remember, we thought that point was correct anyway, and we actually already proved it was correct. Now we're finally correct, which we had already done before, so we kind of. All right, so that took longer than it was supposed to take, but you guys still have a bunch of practice time. So Go ahead and I want you to do the practice problems that are related to example 3. So that was an example 3 straight from your book. So if you want to do example 3 in your book, if you need still an example to follow through, you can do that. And I would suggest maybe start there unless you're positive you got this down. I'll show you the pages again. So again, you can do example 3, page 33, and that, remember, the examples to the right, they tell you what you need to do. So if you're still not sure about this, it writes out in words what you're supposed to be doing in the examples. So you can try to walk through that one yourself. Then, once you get that, go to page 38, and you're doing 19 through 30. And I'll give you at least 20 minutes to practice before we do a super fast review of that partitioning stuff from last time. So you got at least 20 minutes. Well, we'll see if everybody's crushing it, then it's easy. Oh, crap. Shoot. I need to show you one real quick thing. I took a very long version of this. This is how I finally figured out what I was doing wrong. What did I really do down here when I was looking at the endpoints, right? And I used the X values. There's a way easier way to do this. I didn't want to show you this. I wanted you to visually see it first. The X values are actually already in the coordinate if they give you a coordinate point. So there are your two X values right there. I just added 5 plus -5 for my X value. I do all that long stuff just to kind of give you I try to give you an understanding before I just give you here's the quick version. Yeah, kids always get mad because like, you went through all that when all you gotta do is add those two numbers in. So for my Y values, I just add 4 and -2, the two Y values, and divide by 2. So when you are doing your practice problems, they don't even give you a graph. All they give you is the two coordinates, the two endpoints, and you just add the X's together, divide by 2, add the Y's together, divide by 2. I still want you to try to understand what it is you're doing, because if you just become a robot, and now let's say on the quiz, I ask you a question that is explain this to me. If you're just acting like a robot and plugging stuff in, you're not gonna be able to explain anything. So hopefully you have a little bit of an understanding. I would always encourage you to look at the questions in the examples that are to the side. So as you're going through and doing the examples, they ask some good questions. You can kind of test yourself and see if you understand them. I use those on quizzes a lot. If I like some of those questions, sometimes we've gone over them. Sometimes we've pretty much always gone over them. I may not specifically go over it, like, because I see it here. It may just be something I already covered. So if I know I covered it, and if I see it's a question here, there's a good chance I'll put that on the quiz. Make sure you're looking at those questions on the side. We're doing, what was the page 38 numbers, what? 19 through 30 or something like that? Anybody have it up? Yeah, 19 through 30, page 38. So you should be good on the easier midpoints like we did earlier, where they're just on a horizontal number line. And now you should be good on the midpoints. Once you practice for a minute, you should be good on the midpoints. If you guys want to move around again to work together, that's fine. Just make sure you're working. I'll be walking around if you need some help as well. If somebody is getting this, I may have somebody else helping out. Somebody is out. Are you asking for bathroom? Oh, you're just saying somebody's coming back. Was anybody else waiting? So we're doing these problems right here, Alexa. You can ask Randy. If you want to go ahead now, yeah. Switch your phone out for me. You can just. Does anybody have any questions right now? Question. Oh, what do they do? If because maybe it's school. When they take the EOC for scale, is there a physical calculator we give them? Is there a So is that a school by school thing that we decide or?
Yeah, so if you're, like, if you're getting into your classes, then all the geometry has to get, but typically, I think they do, because there is one on the computer for them.
And that was my other question, is it just in the computer
But
software?
they can have the computer one, but they're also allowed to have a handheld one.
Now, when you say if we give it to one, we have to give it the same one to all kids.
Yes.
What if they bring their own? I
Um,
thought I read somewhere if they bring their own, as long as it's a.
I think it has to be like a certain approved one.
But let's say it's approved, they can bring their own. Yeah.
That's okay, but I know a
Pretty
lot of
sure I
times,
said.
yeah, I know a lot of times like the county even like distributed a bunch of calculators to the schools in the past. So there
Right.
should be some that the school.
Well, I have, the reason I'm asking is gonna have two different. So I have this
Okay.
one over, well, the one they're using right now, which I was told was like a geometry calculator.
Yeah.
But then I have this one that they gave us. I think I think it was the same year that they gave us those, they also gave us this one,
Okay,
which is significantly different, even though, I mean, they all work pretty much, but some of them, you know how you have to put the number in first, then the negative
Yeah.
sign versus some you do the negative
Yeah,
sign.
some of them are
And
different.
I think the negative sign here is different because it's got the little plus,
Plus,
minus, and this one doesn't have that, so that's
Yeah.
why I want to make sure they know how to use.
Yeah, I would double check, Theo might even know. You did algebra last year? No, okay.
Because I asked him, what calculator to use? I don't have any. So I'm actually giving him all my white calculators because he doesn't have any.
Okay, Alyssa Dingler might,
Yeah, I'll ask him.
yeah, so yeah, 'cause I don't know if the school has a certain one that they use or if.
And I've asked it before and they probably gave me an answer, but I can't, because I didn't teach geometry last year. I didn't
Yeah.
teach an EOC at all last year.
Yeah,
So I'm sure I asked 2 years ago when I did teach geometry, but I don't remember the answer. And it might have, it might have changed. Let me grab my glasses. Did you need me for anything?
no, I was just stopping in today.
Okay.
Yeah, already-
All right. Yeah, I got a good group this year. This is the first year I really taught geometry. Like I taught it 2 years ago, but I only had one class of it.
So,
It was the COVID year, so we didn't do a lot of stuff that they would normally do.
Yeah.
So this is the first year I've really, like, I got four geometries, so four geometry. That's all. So, yeah, so if you figured this out, you see that was the answer that they got there. I'm assuming you just added it by two. They do on the examples, they solve it out for you, and then they also tell you each step. And then now you can go ahead and go to 38 and do, and keep your 30. Once you've done a few of them, they're all extension. We're gonna review, like I said, the partition. All right, yeah, if I ever need anything, I always reach out to you guys,
Yeah,
Tara, or
yeah,
you or
just let me know.
whoever, so
Yeah,
I'm not afraid to do that, so.
yeah,
You'll-
awesome.
You'll know if I need anything.
All right, perfect. Thanks for letting me stop in.
Yeah. Yeah. So what do you need to do? What's the next step for any midpoint? How do you figure out a midpoint? You add the endpoints together and then you do what? Well, if you're doing the formula, you don't have to do that. If you're doing the formula, you add the endpoints together and then you do what? Like even for a basic midpoint, like what's the midpoint of this? I'm gonna give you an easy one. What's the midpoint between, if I have 4 and 6, what's the midpoint? 5. So I add 4 and 6 together, I get 10. What did I do to get 5? 10. Not subtraction. Scissors or something. Oh, you got it. Rarely just. Well, it shows you there when they do. Oh, it's like- yeah, it's what I told you. So you got the top part, but you gotta divide both of them by 2. And that will give you your final. All right. Thank you. So I know that was the right answer. Negative 1, looks good. Looks good. -6/2, good. And that was the answer. Now, again, you feel like you understand the concept too? If I asked you a different question or something about, like, why is this midpoint? Okay, yeah, you're good. We're gonna move on, where you still got, if you wanna mess around with the goal. Correct, but you didn't hit negative. Because if you hit that, what it did is I think I know what you were doing earlier now. If you hit this, it's taking the answer you had in the calculator before, and it's trying to use that to subtract from the front. Were you trying to do a negative maybe earlier? Yeah, that's why you were using this, I think. This is a negative. You're putting a negative number in. He just was doing the same thing. No, who was saying that?
Oh, I was telling you that. What?
No, X is always first. Alphabetical order, first of all. X is the first number, Y is the second number in a coordinate. X, comma, Y.
I said X or Y.
Yep. Read your phone out.
X.
Please. We get to keep that, you know, you add it together and divide by 2 and it's a negative number, yeah. Well, this one. Like that. Oh, yeah, no, absolutely, yeah, you can get a decimal, the midpoint can absolutely be a decimal. I did an example where the midpoint was a decimal earlier. I'll give you another, like, 3 or 4 minutes to practice these, and I'm gonna go into partitioning. So if you're not getting it, raise your hand right now. Feel like everybody's pretty comfortable? All right, one more, I'm gonna go to you next. You got something to show me. All right, so 5 + 3 divided by 2 is work. So what do you do with the other? Together. It is, but unfortunately, I don't like teaching just that super fast, simple way, because if you forget that, most people will forget it by the time the test comes around. Like, I want you to understand what you're doing first, then I'll tell you. But yeah, ultimately, that's all you're doing. The midpoint is to add the 2 values together.
Yeah.
If it's a diagonal line on a graph, then you gotta do that twice. You take the 2 X values down together, divide by 2, or the Y values down together, divide by 2. That gives you the value. Are you guys working together? Did you get the first one? Well, let me see it. He wasn't quite done yet. So yeah, you have it right lane, so when he gets done, you can compare him. If he doesn't know how to get that number, then show him, but I think he's good. Yeah. Once you get. Yeah, I just checked. It'd be different if you weren't using a calculator to do the math, then you might make a mistake. But using the calculator, you get one over 5.
He's still like. Until like. Yeah, so it's all.
All you're doing is find the answer. Five. There's still some calculators. You want to grab one over there? Where's my? All right, squeeze one in for me there. Go ahead and try a few more, man. This is all practice, practice, practice to get this stuff down. These are, yes. Those will be the stuff we did in the very beginning that were super easy, where you just had to do the two endpoints and add them together once and divide by two. That'll be on there. The toughest part is going to be the partitioning by far, which we're going to review again right now. We're gonna go over them real quick, and then I'm gonna move to review partitioning. All right, so let's compare some answers real quick, and then I'm gonna review the partitioning stuff. What's the answer to number one? 4,6 is what you should have. Again, if you don't have that, write it down to the side, try to figure out what you did wrong, and then 4,6. Yeah. You did what? Well, it's not a fraction. It's not a fraction, remember. So that's a good point. So really quickly, this is an X value and a Y value. It's not a fraction, like that's not one number. It is two separate numbers. So it's 4,6. So it would be an X value of 4, 1, 2, 3, 4, and Y value of 6. 1, 2, 3, 4, 5, 6. That would be a point on the graph like that. 4,6. I'm sorry, number 19. Yeah, it's the first problem in this practice. What's number 20? 5, comma, -1, I think, right? Is that what we got? 5, comma, -1, right? What's number, what are we on, 21?
Yep.
What's 21? Should be -3 is your X, -3 is also your Y. I'll do one more, and then if you, again, jot the right answer down if you didn't have it correct. What's number 20, whatever we're on, 22, is that one? 19, 20, yeah, 22, what's 22? 4.5 is your X, and then 2 is your Y, so 4.5, comma 2. So that would be the point you would put on the graph. So again, if your answer was 4.5, comma 2, you would go to the Y or the X axis and go to 4.5 and then go up to 2. That point would fall on the line that was created, which they didn't get. Oh, actually here, tell you what, let's do that. I didn't do this for the other classes, but we'll do it. I'll get rid of all of that. What were the points for whatever we just did, the 4.5, comma 2? What were the original points they gave you? So 7, comma 0 would be here. What else? 2, comma 4 would be here. So that creates a line that goes right from here to here. And then we figured that the midpoint would be what? So we said the midpoint when we calculated it out, 4.5, comma 2. So that point better be on that line that I just drew. Not a bad idea to check your answer if you have time, like draw out a line and make sure that point falls on the line. So 4.5 is my X, 2 is my Y, and sure enough, even though I drew it by hand, it's still pretty good. Falls right on that line, and it does look like it's also the middle of that. All right, so let's do a real quick review of partitioning. I don't remember if I did a partitioning on a coordinate plane, so we're gonna do that. I might have, it might be review, but, oh, wait. Oh, 3/4. So 3/4 of the way means a ratio of 3 to 1. I didn't really go over how to convert to take a fraction and move it into a ratio, but that's what that would mean. So if I want a point, so I'm going to put a point on that line, point P, that is 3 and a ratio of 3 to 1. What can you tell me right now about the two line segments that I'm going to create? Anybody? Not, I'll ask a more specific question. What do you think? Which segment would be longer? Right. So you're saying this would be about correct? Oh, it's high school. Don't worry about it. That's not important. So is that a viable solution? So let's say I think that's point P. Is that a viable solution? What am I going to call? I'm going to call on Zakaya. Is that a viable solution where I just put that in Zakaya based on that ratio? What do you think? I'll give you a hint. It should be very obvious that it either is or isn't. Why not? What does that mean that it's a 3? What is that telling you that tells you that I can't possibly put it there? Fantastic. That's perfect. So what Zakiah just said absolutely correctly is, well, wait a minute. Mr. Gill told me that when we started ratios, these numbers are comparing the two, basically the two line segments to each other. If this number is way bigger, and this is my left number, if it's my left number, then it's talking about the left line segment. If that's my right number, then it's talking about the right line segment. This number is telling me the left line segment is way bigger, 3 times bigger to be exact, than the right. Is my left line segment bigger than the right drawing that I just did? Oh, absolutely not. Not even close. It's way smaller. That cannot be a correct point. I will maybe give you a line where I don't give you any numbers at all. And I just put a point somewhere in the middle and I say, could that possibly be correct? And the answer would be what we just talked about. You'd either say, well, yeah, maybe, because based on the ratio, it would need to be, the left side would need to be bigger than the right. Or the answer might be no, it's not correct, because again, same reasoning, based on the ratio, the left should be bigger than the right. So that's the kind of question you may get where you don't solve anything out. I just ask you to explain whether or not what I gave you is a viable solution. And that is the kind of question that takes you from a 3, where you just do a process and repeat what we did, to explaining that you really understand what we just did. All right, so now let's actually figure out where it would go, because that is not right, like we just said. All right, so I have the endpoints. Again, anytime I have the endpoints, I'm going to go ahead and write what the, there we go. I'm going to go ahead and write what the ordered pair is. So this is negative. Let me make it so we can see it. I really need to just change that permanently. So this is, just assume that it does go all the way there. I think my line got crooked at some point. So this is -5, comma, what is it? -2. Hopefully you know how to tell where a point is. I'm not going to do a lesson on that. This is +5 and 4. So 5, 4. All right. So now here's how you partition when you're on a coordinate plane. It's kind of like what we did for the midpoint. We're going to do the same exact thing that we did when we partitioned just one line. We're just going to do it twice. We're going to do it once for the X values, which means we're going to draw in that same triangle we did before. And we're going to do it once for the Y values. So I'm going to take this line and partition it into a ratio of 3 to 1. And then I'm going to take this vertical line and partition it into a ratio of 3:1. And when I get that X and Y value, it better fall right on that blue line. Although this one might be a little off because my blue line is not in the correct spot. Should be pretty close. So how do we change a ratio into a fraction? We do. First number. So there's our rate, and that'll be the ratio we use twice. We'll use that with the X endpoints and we'll use it with the Y endpoints. What are my X endpoints? Oh, what's the second step? Just let's repeat this step before we worry about doing it. First step is change the ratio to a fraction. Second step was what? You gotta find. You don't have your notes out, or if you don't know it, you should have your notes out to help you remember this stuff. We need to find the length of the line. So in this case, we're gonna do this line first. How do we find the length of a line? You can count if you have numbers. If you're on a coordinate plane, you can just count how long it is. But yeah, subtractions to me with a if you've got a calculator, which you will, I'd just say +5 subtract -5 is what? No, you can't have a zero length. That should be your first step. That's 10. Do it in the calculator if you don't. +5 subtracting a negative is keep change flip. Changes to 5 + 5. So that's 10. So I guess I could write that. 5 subtract -5 equals 10. Now I have the distance or the length. I have my fraction. What do I do with those two? I multiply. So third step is to multiply them. So I say 10. You can do fractions in your calculator. Times 3/4 equals 15 halves, so 7.5. You did it in your calculator. You can correct me if that's wrong. So I got 15 halves, or I guess I'll write 7. I hope that gets rid of that. It does. So that's 7.5. So what does that 7.5 represent? I say when you figure out that number, what's that mean? What's that represent?
Length of the first segment.
Fantastic. So that is the length. I'll call it the left segment. So that is the length. Again, right now I'm only talking about this horizontal line. So that 7.5 is going to be the length of this first segment, which would go to about right there. Now it's a little different with a coordinate plane. I'm going to still add it to this because remember, we're going to wind up going diagonally eventually. So we're not really going left and right. I do still need to come back and add 7 points. So this is step 4 of our process. Add 7.5 to your original starting X value, the -5. So if I say, where will I do it? Here, we'll do it over here. 7.5 plus -5, I get 2.5. That's the X value that will be our point P. So I'm going fast, I know, but you have to practice on your own. You'll have this example recorded though to use also. So that's my X values. Now I just repeat everything I just did, only I'm going to use the Y values. Instead of using -5 and 5, I'm going to use -2 and +4. So I've already done this. The ratio is still 3:1. So I've already got the fraction. What's the length of that line? You could just count the length. What's the length of that line? The vertical line now.
6.
Yeah. So if I'm going from here, 1, 2, 3, 4, 5, 6, or 4 subtract -2 is +6. However you get the length, that's all that matters. You get the length. I'll do that again individually. Yeah, we got a minute because I want you to try one of these on your own. So now I have the 6. I need to come back up and multiply it. Actually, I can do it right now. So I'm going to take the length of the Y segment, multiply that times 3/4 to put a fraction into your calculator. Hit 3, hit the A, B, C button. It'll put a little guy right there. and then put in the 4. And you should see that exact thing, and so you could say that times 6 should give you 9/2, I believe. Not, let me know. So that gives you 4.5. This will be the length of the segment that goes from here to here. So it'll be 4.5 out of the full 6. But what we ultimately have to do is add it back into this number, the -2. So we always use these because this is the starting point. We use the starting X and the starting Y. So 4.5 plus -2. Now room. 4.5 plus -2 is positive 2.5. Oh, look at that. So I got 2.5 comma 2.5. Now this is just like when we did midpoint. That better be on the line. If I'm separating the line into sections, I better still be on the line. If that doesn't wind up being on the line, then I did some math wrong. So again, you kind of have a built-in check to this. So I'm going to go to 2.5 up to 2.5. Sure enough, that is right on that one. So I'm pretty comfortable I did that right at this point. So I know I went fast. It's recorded though. If you need to go back, better yet, just go ahead and practice one on partitioning. You'd have to go back to the last practice page, which was probably page 32, is my guess. Oh, no. Oh, no, 31 is where you started. So yeah, you'd have to go back to like page 30. Oh, farther back. Go to number 9, 10, and 11 on page 28. So try to do, I don't care which one you do, you can pick one. They give you a whole bunch of lines, so just make sure you pick the correct line. So page 28, try 9, 10, or 11 while you got me here. And then did somebody have a question? Oh, no, I just showed you how to do the traction. You got 7 or 8 minutes. This is your last chance to practice what the hardest thing on the quiz is going to be next week, partitioning. Well, actually, specifically, partitioning on a coordinate plane. What did I say? 28, is that what I said? 9, 10, 11 on 28. Yeah, I'm pretty strict about following that 10-minute rule because the main reason is because that's an email from my principal, Mr. Patterson, that says, don't do this. And unlike some teachers, I do what my principal tells me. Most teachers don't, which I don't understand. 9, 10, numbers 9, 10, and 11, I think on page 28. But you're looking for 9, 10, and 11, whatever you call it, somewhere around page 28. Yeah, if anybody wait, yeah, if anybody has second lunch and you ever want to come in, like, for some extra help, I typically am in my room, not doing much. Sometimes I'll just walk next door and the other teachers eat in there. But if you catch me before I get over there, yeah, absolutely. There's also G2. If for some reason I'm not around, you can go to G2 for either lunch if you don't have a second lunch. You guys could actually do that on Monday also, because I don't see you until after lunch. So you could actually come in here Monday also, right before the quiz if you wanted. That's not a bad idea since you guys are after lunch. Come to me right before. So you'd literally sit in here, tutor, and then right after that, I see you 6th period on Monday and you could do the quiz. So it'd be right before. So either tomorrow or Monday. If you have a question, let me know. There's not tons of time, so I'm pretty much just gonna answer questions that people have instead of. You can handle this, then you should be in pretty good shape for Monday. This is by far the most challenging thing you'll see on. In my opinion, maybe other people would say differently. Oh, I don't think I did attendance. Or did I?
worst part is that it's joke.
Nobody sits there.
We had so many birthdays. I'm so tired.
I can add her to fifth grade.
Let's just do this.
Oh, oh, stop recording.
Thank you.